All right, fully live on a Saturday. Sorry for the slight delay from scheduled start. Very glad to be here, and thank you for all of you who are joining me on a Saturday afternoon. Saturday day to day is what I like to say. We'll have a very special stream today. Fighting Churn with Data Masterclass. Isn't that dorky? I get such a laugh out of it. But anyway, I got to keep a straight face and keep going. Fighting Churn with Data Masterclass, Stream 3, Event-Based Feature Engineering. Gonna be a good one. It's been a crazy month in the world. Since my last stream, there was the whole OpenAI blow up. Sam Altman leaving, coming back for mysterious reasons. Worried that they've got artificial general intelligence, cooking up somewhere. But here it's just good old fashioned churn, data science, feature engineering, more working day data science stuff. So without further ado, I'm going to jump right in as I like to do. I'm actually going to start with I'm going to start with an opener, which is going to be a wrap up of the last stream. I don't know if any of you were with me then. It'll be a quick lesson on advanced churn rate analysis. I didn't really do it justice at the end of the last stream. I kind of rushed it, and I realized afterwards I didn't make all the points I should have made. So we're going to look real quickly at comparison of the churn rate varieties using the multi-churn rate calculation, which was done at the end of the last stream. So I'm just going to go straight to the code, which is what most of us are here for. And this was let's see, I hope it's clear in the screen. Yeah, that actually looks okay on my monitor. Okay, yeah, so this is the churn rate multi-part calculation. Let's actually start with net retention version. This is listing 2.8 in the source code. It uses a bunch of CTEs, common table expressions, which I'll step through right now. First, we generate a series of dates. So this is a more advanced version than was in the Fighting Churn with Data book. This was added after the book was published. So we start with a series of dates, and then you find how many accounts have started and what their total monthly recurring revenue is for all of those series of dates. And you use the subscription table to find out if the account is active. And then you do the same thing for all the end dates. And then an inner join will actually tell you who are the retained accounts. This is one of the basic techniques from the last stream. You use an inner join to find retained accounts. And then we compare the start monthly recurring revenue and the end monthly recurring revenue to get the net retention rate, which is the retained MRR divided by the starting MRR. Okay, that's net retention multi-month calculation. And then we can do the same thing for a standard churn rate, which is shown here. In this case, we're not summing MRR, we're just looking at what accounts are active. And the key to finding churned accounts is an outer join. So we outer join the starting and end accounts and take those where the end account ID is null to find the churned accounts. This was another key point from last stream. And then we calculate the churn rates. And here, actually, if you look closely, I'm also doing something else that was covered in the last stream, which is calculating the annual churn rate. This is a monthly churn rate calculation because we're going over monthly intervals shown here. And this 1 minus the churn rate to the 12th, that's your annual churn rate calculation. That was also gone over in plenty of detail in the last stream. And finally, somewhere around here, I should have a MRR churn calculation. Looks like I don't. Which one's MRR churn? Here we go. MRR churn. Same concept with starting and ending accounts, but this time we're calculating the monthly recurring revenue. And also, when we look at the churned accounts, we look at the churned revenue. This is using an outer join, and then the downsell revenue, which is actually an inner join like net retention. Inner join start and end accounts to get the downsell revenue by putting a condition on the MRR decreasing. There's a little technicality about the billing period here. I'm not going to go into that on the stream unless someone really wants to. Let's probably not. Anyway, this is a more complicated sequel for the MRR retention, but I'm not going to go into it. But let me go back to, let's run it and look at the results. That's actually what I wanted to do. I have these all set up. I cleaned up also my run configurations since the last stream. If you saw the last stream, I kind of entered these configurations, and now I've actually renamed them a little bit better. And here I'm going to run all 3 listings at once, listing 6, 7, 8, which is something you can do with the Fighting Churn with Data code. And let's see, do I feel lucky? Is it working? Yes, it looks like it's working. Yep, some results are flying by. And so in this case, I saved all these results to local files. So let's find those local files. Let's see. Oh yeah, that was my sound check file. We don't need to look at that. And really, we only need to look inside this one directory. How do I close all this other stuff? We don't need all that. Okay, so these are the outputs. I hope that is big enough for y'all to see. Let's see, that's a little bigger. All right, I don't know. Anyway, so this is the net retention result. I guess let's open the churn rate result first. I'm just gonna double click them, which for me opens them up in Microsoft Excel. Sorry to be using Microsoft Excel, but it is just so convenient. So here's our churn rates and our annual churn rates that we calculated for the simulation. Now let's also look at the MRR churn rates. Again, opening them up over here. And I think I'm basically just gonna like copy these over to my other window. And finally, let's look at those net retention rates that were just calculated. I did a pretty bad job of explaining this last time, I think. Let's see. All right, so now that we've got these all together, I'll just do a quick visualization. Again, just kind of like taking advantage of the convenience of, quick and dirty with Microsoft Excel. I suppose to be a true Pythonista, I should be doing this in a notebook. But, in business world, it's much easier to share, spreadsheets with your coworkers than notebooks. So let's just make a chart of the annual rates. I think that'll be the most interesting thing. Also, something you'll notice is there's kind of like a startup effect at the beginning of the simulation for some of these. So I'm gonna like skip, maybe I'll start after like 6 months. There's kind of a burn-in period. All right, so let's make a chart of the monthly churn rate. Here, okay, so churn rate, this is actually annual churn rate. Sorry, not monthly, that was the whole point. This is our annual churn rate from the simulation. Now let's add some more data. First, we'll get the name on this one. And then let's add another one to the data. So we want annual MRR churn rate, I think. Annual, what's this one? And so we want, then I skipped the first 6 months or something. So it's 6 to 24. And lastly, let's get the annualized net retention, which is going to be over in this column. Whoops, what, oh yeah, sorry Excel, no, now it's going to punish me, and like, I better get these results here. Oh wait, wrong one, I need 6 to 24. Sorry, this is taking a while, but I'm doing it live. What is the problem now? Okay, I give up, hold on. Oh damn, I lost both of them. Okay, embarrassing myself on live stream here by not successfully navigating Microsoft Excel. Let me slow this down a little bit. All right. Let's add another series, and because this was embarrassing, didn't work the first time, I'm going to do it more slowly. Let's try just adding that one. So here we actually have the result for a comparison of the churn rate and the MRR churn rate. Let's add a legend because I took the time to name them. And what you can see here from the simulation, is that the MRR churn rate is generally less than the churn rate. And this is an effect of the fact that there's multiple tiers of customers, and the big customers who spend the most money churn the least. So that's why MRR churn rate tends to be lower than churn rate. Let me make this a bit bigger so people can see. And this is faithfully reproduced in the simulation here. Looks like there's a big month for MRR churn this 1 month. That's kind of interesting. No clue what happened there, but it is random simulation. Okay, lastly, let's add the net retention rate. Back to my select data. Now we'll add the annual net retention. So this is not a churn measure exactly. Let's see. So net retention includes both churn and upsell. Whoops, that actually doesn't look so good. I should actually do like 1 minus net retention. So you can see, anyway, the net retention is greater than 100%, which means that the upsells to more expensive plans actually cancel the downsells. What I could do here is I could say, I could fill these in with subtract 100%. Let's change this so we can get a better looking chart here. We'll change this one to be O. Okay, and now we can see net retention minus the net retention minus 100, which is like your the money you're making in excess of churn from upsells, is annually hovering around 5 to 10%. It is pretty variable from month to month though. So yeah, so that's the result. I'm gonna just like save this for posterity, because this way I'll have a record of everything we did on this stream in the output folder. And so yeah, so that is the churn rate comparison that I was going to do from last stream that I never really completed, like I said. And that was from the GitHub repo, Carl24K, fight churn. Churn rate, multi-SQL listings, actually 2.6, 2.7, and 2.8 are 3 different versions of multi-month churn rate calculations. Again, that's advanced material, was not in the original Fighting Churn with Data book. All right, so what's next? Well, that was my opener, a recap from last week. Now, I'm gonna give my little background. I see there's only a few viewers today, so you guys probably all know what is churn, but I have to do this every stream because actually this is gonna go up in YouTube and be in the Twitch VOD. Oh my God, can you hear my dog freaking out in the background? I have a lovely, lovely mixed breed dog who's been with my family for about 10 years now. He's lovely except when someone's at the door, and then he freaks out and barks. So I don't know if you could hear it. Anyway, what is churn? Churn is subscribers, customers, or users who cancel, unsubscribe, or unfollow you, whatever it is. It could be retail where they just stop buying stuff and you would consider that a churn. The origin of the term is from a metric called the churn rate, which is the percentage of customers who are dropping out. And churn is also now a verb. You can say the customer churned, or I'm churning from Hulu because all their stuff sucks now. And you can make it a noun. Make a report of last quarter's churns, or make a churn report, or even that customer is a churn, they canceled their subscription last week. So if you're in the business of subscription, there's lots you can say about churn. And just want to say out to those in the Twitchiverse, I'm happy to take comments, questions on the chat. Let me know where you're streaming from, and also let me know what social media you found out about this. If you found out about this through a social media, I posted this on Mastodon and the service formerly known as Twitter. Always curious to know where people are actually coming in from. In fact, my publisher wanted to know where we're getting engagement. And God, I don't even know. Anyway, moving right along, what is Fighting Churn with Data? If you don't know, it's the book that I wrote. It was based on my experience back at a company called Zuora, where I no longer actually work, but I had a good couple of years at Zuora. Loved the people there. It was a great company. After they went public, I moved on to new startups. I'm on my second startup post Zuora now, which is a startup called OfferFit. I can say more about that if anyone's interested. But the book was really written at the end of my Zuora days, and it was based on the churn data science analysis that I did with the customers there. And now today's stream is actually like a more advanced version. This is kind of a warm-up material for if there's ever a second version of Fighting Churn with Data, you'll see some of this material. Well, you're getting the advanced now. Anyway, there's also a discount code here. If you do not have the book and you're interested in buying it, don't buy it without getting a discount. Or you could go to Amazon and get free shipping, but that's your call. Anyway, moving right along. What is Fighting Churn with Data really? It means using data to reduce churn through different types of data-driven churn reduction. That could be making a great product and use your data to find out what customers love. It could be engaging with your customers through marketing. It could be giving your customers support and having your customer success team, interact with the customers and using your data to know which customers to hit up who need help. And sales and pricing, it could be right sizing plans. I say without discounts, and that's what I say very often. But currently, actually, my job is using discounts. At OfferFit, we use AI to target discounts at the customers most likely to respond with the best ROI. So while I say no discounts, it's really no discounts unless you're using an advanced method of targeting. But we can talk more about that in a future stream. Today is more foundational. Although the techniques that we're using today absolutely apply to targeting things like discounts with AI. Oh yeah, actually, I've got my OfferFit mug here. That's actually our old logo. I might get in trouble with our marketing department if they see that I had our old logo on on a live stream. Anyway, why would you want to learn about churn? It's the most common data science problem in the world. And I say that because every company has a churn problem that they want to solve. Nowadays, everyone wants recurring revenue. But there are some special tips and tricks to churn, which you can learn on the job, learn from friends, or learn here with me or from the book. Also, in this stream, I really build up data science from the foundations. And today is actually really going to be a perfect example because we are going to go from raw data to machine learning features. In fact, is that my next stream? Perfect segue. This is a real foundation of doing practical data science, which is going from raw data to features that you can use for machine learning or whatever other purpose you want. So today we're going to do event-based feature engineering. And I think I'll just dive right in. The next step is probably to take a quick peek at the data. So what data are we using? There is some simulated data sets. One is the social network simulation, which was shipped with Fighting Churn with Data, and that's described in the book. And recently I've released a much more complex and interesting simulation, which is based on a CRM, or customer relationship management tool. And so we're going to highlight the CRM simulation in today's stream, because the social network simulation was pretty much beat to death in Fighting Churn with Data and my past streams. And in fact, the whole point of doing it was so I wouldn't get bored. And hopefully people watching this don't get bored too. But anyway, so let's take a look at the data. I have something open right here. Always good to go for some code. And let's see, is that font visible for y'all? Yeah, that looks not too bad. So first, I'm going to set to the CRM. I guess it's a schema in Postgres. Oh my God, I'm so bad. Is it a schema or a database or a data set? I mean, the term is different in different systems. But we can look at what we've got in this schema. First, there's a bunch of accounts, 5,000 accounts, and these accounts all have an ID, a channel, which refers to how they use our app, the simulated app. They have a date of birth, etc. Although in this case, they're companies. They're meant to be companies. So that's why the date of birth is really like a company founding date. But I didn't rename the schema. Call me lazy. You can wait for that in second edition of Fighting Churn with Data. But let's look at, there's also this event table, which we did not, in the last stream, we looked a lot at the subscription table. And that is the basis for all those churn calculations we were just doing. But now we're going to look, today we're going to spend a lot more time on the event table. So the event table has a lot more data in it. Let's see, I have to count the places. Is that like 900 million events, or no, 90 million events. We have 90 million events for our 5,000 accounts in the table here. And here I've written a join to show you the names of the events. Well, I can show you the events first, and then you'll see why I wrote the join. So here's just a little selection from the event table. And you can see that we've got account IDs, times, and also event type IDs, and also user IDs. And the user IDs is also a new feature of the advanced simulation. So let's see. So this is what the event table itself looks like. That's not very informative. We've also got another table called the event type table. So I'm using a good normalized database schema because this is Postgres. I don't want to repeat the strings that are names of these events 90 million times, because that would just be wasting space on my own hard drive or whatever network server I'm using. So we join with the event type table, and now we can actually look at what these events are. Wow, looks like this one it doesn't take that long. It took a few seconds. This is a host using my Google Cloud hosted server, not my local laptop. I learned that the hard way. Don't run a database server on your local laptop while you're streaming. Aha. Has anyone on chat ever done that? Nope, quiet crowd today. But anyway, I'll just keep on going. So these are the events from the CRM simulation. There is searching in the CRM. Also, you can create, edit, and delete a search. Winning opportunities. If you know the lingo of salespeople, winning an opportunity is pretty much the most important thing. That means that your deal closed and you're getting paid. So that's a very important event. Advancing stage is another interesting event. If you know how CRM systems work, there is a stage assigned to each deal or opportunity. They call the deals opportunities. This is like Salesforce lingo if you're not familiar. So advancing stage means you go one stage closer to the deal closing. So advancing stages is a good thing. Adding competitor, disqualifying opportunities. So these are all simulated events that are meant to represent the types of things that people do in a CRM system. And our churn model is based on what happens with all these events. What each account does with the system tells you how happy they are with the product and how likely they are to churn. So that's going to come in a later stream. Today, what we're going to do is work on taking these raw events and turn them into usable features for machine learning, or metrics for your analytics, however you like to say it. So for a quick comparison, I'm going to switch over to the SocialNet 7 simulation. This was what was in the book Fighting Churn with Data. Oh, actually, I need to adjust my dates. That's why I did not get any result from the social network simulation, because I believe the book is in like 2020 days. That was when the book was published, right? 2019, 2020. Maybe I should just get rid of the, oh no, well that worked. All right, so here's what we had in the Fighting Churn with Data social network simulation. Only 7 events, so much simpler, that simulation. It was the best I could do at the time I wrote the book, but now the CRM simulation is kind of a lot more interesting because there's more variety of the events that we can analyze, more potential interactions, more ways they might help your machine learning model. That's still running? What happened to this one now? Oh no, I know what happened. I changed my search path. How come no one out there is helping me with this? You should be on chat. Dude, you have to set your search path back to select from the CRM schema. Okay, well that answers the step of where is the data? Okay, there is some data. So now where's the code? How are we going to do this feature engineering? Well, I think I'm actually going to do a little bit of talk without code first. So this is an illustration of the subject of today's stream. It's feature engineering in the database, which is a big difference from what some people say. Oh, hey, thanks, Challenge Project 43. It's nice, always nice to hear that people actually like the book and it made a difference in their lives. It actually really makes it worth it because the money was not worth it. Let me tell you, if you write a technical book, don't expect to, retire on it. Anyway, so thanks for the shout out. So if you read the book, this is very familiar to you. If not, let me explain. We are going to take the event data from that we just saw on the table, and we're going to do aggregations over customers and time. And then I'm going to save them in another table, which I called the metric table. So your event data is kind of big. Remember I showed you there were like 90 million events for this small CRM system over, I guess the simulation spanned a few years. We saw that in the churn rate demo at the beginning of the stream. And so then we're going to aggregate them into a metric table, which is also going to be typically in your data warehouse. At my current company, OfferFit, we do this all in Google Cloud in the BigQuery system. And at my last company, we did this all in Snowflake. And at my company before that, we did this all in, I think it was Athena. AWS hosted Athena. So you can really do this in all types of systems, but for this project, I'm just doing it in Postgres because it's just easier to manage locally on your laptop. So this is the idea, and let's make an illustration now of these types of aggregations. Okay, here's the concept of event-based features. You have a bunch of events. Say it's like user logins, and user 1 logins at a bunch of points in time. Login, login, login. User 2 logins at some other points in times, and you want to make a comparison, but that's hard because these are point in time events. It's just not very easy to work with. So we're going to divide the time up into months, and in each month check how many logins they had. So user 1 logins 2 per month in January, 4 per month in February, etc., etc. User 2 logins, actually you can tell user 2 is a bit more of an active user. 4 in January, 6 in February, 4 in March. You actually notice I'm doing 28-day intervals in this example, which is considered to be a best practice because behavior on online services follows weekly patterns. very commonly. And so that's why it's a good idea to generally make your feature calculation, the aggregation time window should usually be a multiple of 7 days for shorter time periods. Once it gets up to a year, you can just be like a year, 365 days. But for like months, it's better to do 4 weeks than like a calendar month or 30 days. Anyway, so this is the concept. That's your mental model. This is a little toy calculation for one account, where suppose we have just one account, one event type, and events at different times. I drew this picture actually for the book because the publisher is very particular about having clear images and mental models. It's part of their like mental model of learning. So it seems like a simple example, but it's good to start small. So we divide time up to periods, and you can see how each period you just add up the total number of events, and that can give you the basic metric. All right, so how are we really going to do that? We're going to do it with SQL. So let's head over to the code and look at listing 3.1 from the book. Let's see. Whoops. Gotta get rid of this output window. Close chapter 2. Actually, let's keep things a little bit neat up here. Now we'll go to chapter 3. So this is a very simple SQL that will do the calculation that was just described. There's basically, in the first CTE, there's just one date labeled the date. And you might wonder, why am I doing that? It'll make sense later, trust me. Here's the query where we select by account ID and do a simple aggregation, count star from event, where the event time is on or before the date and after the date minus 28 days. So I've defined a 28-day interval, like I said. Now here, actually, I don't actually say what the event is. I've got a bind variable, which will get plugged in there. And also this date will get plugged in from a bind variable. And if you dig in the guts of the Fighting Churn with Data code, there's like a configuration that saves all this stuff, which we'll actually be looking at that soon enough. So let's just run this first. I actually, for once in my life, I prepared for a live stream by preparing a command to run. Which is basically just the same as all the other ones. I'm just running chapter 3, listing 1, and I passed the schema argument. But I did prepare this in advance to make my first SQL of the day easy peasy. Okay, so what was the event name here? Was advanced stage. That was one of those CRM events, which means that the account had an opportunity and the opportunity advanced to the next stage. And here we've done the SQL. Account 0 had 23 advanced stages. Account 4 had 35 advanced stages. Oh look, account 20 had 50 advanced stages. So there's a big range of values here. And so yeah, that's the basic. This is the basic feature calculation for event-based data. But don't quit yet. Don't leave the stream just because I've already told you everything there is to know. There are some interesting details that will come in a few minutes. So that was the first step, listing 3.1. The next trick is, that was fine. We calculated the metric for one date, but it doesn't seem that efficient because we are doing this in a database, and databases can do things at scale. And this is a way to calculate your features at scale for many different points in time, because we don't actually just want to know what was the feature calculated at a single date. We're going to want a time series of those. So how do we do that? You can imagine just breaking up time into windows, and also using overlapping windows. So this is, let's say you can make this on the bottom row, it's calculating the user 1 logins per month with non-overlapping windows. But actually you can keep better track of the data by calculating features repeatedly at overlapping lags. So every day or every week, you have an updated value for the feature. You don't have to wait till the end of the month to update your features. For the reinforcement learning we do at OfferFit, we calculate features updated every day in a manner just like this, using lagging windows, that advance in time to calculate the latest value of the feature for each customer. Now we're going to do a slightly lower weight version of it here, which is doing weekly calculation of monthly features. So here's the idea that if in month 1, at a 1 month interval, we'd have the green bars like 2, 4, 2, 1, you can do the same calculation at weekly intervals and kind of see how it progresses mid-month. So if you were doing a calculation, or if you're using this data for prediction in the middle of the month, you want the most up-to-date value for the feature. So now this is easy to do in SQL as well. Well, first we'll show you the toy problem. This is the toy problem where we have the same series of events as in the last toy problem. Here's a new toy problem. But now the start and end dates of the periods are overlapping. So you get intermediate date calculations for the features. So that's that's the toy problem illustration. This is also in the book, but let's go to the code, and you can see how this works out in the code. Also, how's the music volume? Anyone out there like the music volume, the mic volume? No one's complaining, so I guess it's okay. I can hear the music fine, but I think you guys get like the different volume than me. Anyway, so here's the multi-date calculation. Now this actually makes clear why did I have this CTE for the calculation date when it was just selecting one date. Well, it's a little bit more meaningful now because I'm actually making a series of dates. And this is a Postgres trick. There's similar tricks for other databases that people use. So we're going to select a series of dates, and like I mentioned, doing weekly interviews. This one's hard-coded to a weekly interval. What did I say? Interval. 7-day interval. You could do a 1-day interval as well if you wanted to calculate daily features. But it's the same aggregation. We aggregate by account ID, the metric date, just a simple count. And we are doing this where each event time is within the metric date, and the metric date minus an interval of 28 days. And we join on the event type so that we name the feature, the event, rather than using an ID or something, which we saw when I did the live SQL at the beginning. Okay, so this is the event type, the event count query multi-date, and I'll just duplicate this one, call this 3.2. By the end, I'll have a complete library of commands. I'm not really sure if I need to, but let's just take a look at the output of this query. Okay, this is what happens when the bind variables are filled in. We're running from 2022-01. Actually, I'm calculating 2 years. Maybe that was excessive for this little demo, because only the first couple of rows fit on the screen. But whatever. So this shows how this account numbers of advancing stages has varied in a 28-day lagging window over a few months period. You can actually see it's pretty variable actually. I'm actually surprised. It seems to jump around a lot. But that's believable. So cool. That's how we do a multi-date aggregate feature calculation. And like I said before, we are supposed to be saving these back into the database. And that's like the one thing we haven't done yet. Is we want to actually take the result of this query and plug it into the database. So that is the final step that we'll be doing. So let's look at this one. We're going to look at the metric insert, and then I think I need to actually set it up. But the insert version of this is really just like we've been doing all along. it's we take a date series that we want to do the insert for, and we basically just this was the aggregation query that does the metric calculation in the previous example, and now we're just going to insert this value into the metric table for this schema. So there's not much to it, except I don't believe I've actually set it up. So, there's another part of this actually I should mention. I put things in slides so I don't forget. That's actually the main purpose of the presentation slide deck, is to remind the presenter what to do. Hey, actually, Challenge Project 43 had a question. We love questions. The way you built your data set, you'd like to have every customer in multiple rows, and for every row, the probability that is given by the machine learning model. Now I'm wondering, what does this actually translate to? Oh, wait a second. I have to read that question. That's long. Okay, for multiple dates, actually, we don't use the calculation at every row. We actually take an observation for every customer right before their renewal date. That's actually... So we do take multiple observations of each customer in the data set, and that's why we make multiple date metric calculations. But what we're gonna do in the next stream, or maybe the stream after, is you want to observe every customer right before their renewal date on the product, and then you make an observation with their metric or feature values 1 month before their renewal date, and then you take the feature values for that date, and then you wait a month and observe the outcome. But so you really only need every customer's features calculated before their renewal date, at some fixed interval before their renewal date. But that's actually kind of complicated, and generally I separate the two processes, and I just calculate the features at a regular interval, possibly daily. Weekly is a good compromise, and then I have every customer's features calculated every week, and it's convenient for all kinds of analysis and quality assurance. And then at a later stage, I actually look and see when their renewal dates are and sync up the features with renewal dates. Let's see. Some people build their data sets from a customer perspective, meaning in each row you have a unique customer, and then when you produce that probability, you basically say to the business people that basically this customer has this likelihood of churning. So it makes more sense. That comes at a later stage. After you have a model, you can use it to give the churn probabilities. That all makes sense. And then you produce probably. So I'm not sure actually what your question is. These are all good topics of conversation, and it all makes sense to me. But what did you mean by what does this actually translate to? Well, we have to fit a model and come up with the churn probabilities, and all that comes later. This is going from the ground up here, so we've got to this is the foundation of building the data set. I'm actually double fisting. I've got coffee in one mug and a throat tea in the other. This is live streaming. Okay, so you think that's a subject that we're going to get to later on. Well, then let me get back to reminding myself what I was supposed to do. Oh yeah, I think it was that along with this query, there's supposed to be another one where we insert the metric name. This is another query I'm going to have to use because we want to have, metric names in our database along with the data. So let's see, where were we? Let's see. The next step was going to be actually running the program to insert the metrics. So there's the way you can run this in Fighting Churn with Data for the social network is to use chapter 3 and do listings 3 and 4, and versions 2 through 8 are the book listings. But now I'm actually going to do something slightly weirder, which is I haven't actually configured everything for my new data set, which is kind of annoying, but I'm actually just going to do a live demonstration of messing around with the Fighting Churn with data configurations to set them up. And what I have to do, I'm going to demonstrate, is get into the configurations, which are, I think it's in the, God, I don't even remember. It's in the listing directory. Here we go, in configuration. So I want to add some configurations to the CRM6 JSON. I'm just going to collapse everything. So the way this is structured is I've got configurations for each chapter and each listing. And actually, I've done a bunch of stuff in chapter 3 on this data set already. But I actually don't have listing 3 set up. So what I'm going to do, like any smart person, is I'm going to look at another example, the SocialNet 7 from the book, and I'm going to copy paste it in. But then I'm going to set it up to actually work with, my new data set. So let's just copy this much, and hopefully I can paste this in without messing anything up too much. I think I need to close my curly brackets and add a comma because this is JSON. So this was what I had for Fighting Churn with data. The event was like, because it was meant to be the social network. So now I have to update this to the correct events for the CRM simulation. So the first thing I'm going to do is go back to my data set. I actually want to check, okay, the event types go from 0 to 24. So I'm going to need to make 24 of these. And I also need actually these strings. So what I need to do is make 24 entries with these strings in them. So I'm actually going to start by copying all this out. And since I think I still had Microsoft Excel open, I'm just showing you how I live hack when I set up these configurations, if it's ever helpful for anyone who wants to do this. So now I've got my event types, and what I need to do is make entries like this one that have the event here. I think there should be an event ID too. Something looks like it's missing. Let me look at this number 2. Yeah, there's supposed to be a new metric ID here too. I guess I didn't have it in the first example because it was a default parameter. Let's go back here. All right, so I'm supposed to have a new metric ID and an event to measure for each one. And I need to do this a bunch of times. So what I will do is I'm going to do a little Excel hack by, well, I better put a comma here too. That's going to give me like, these are giving me JSON errors for now, but I'm going to sort this out, I hope. What I need to do is put this into a concatenate cell in Excel. Let's see if this works. Okay, and oh God, I'm gonna have problems with the quotes. That is actually the worst. Oh, maybe this is not a good way to do this. I just realized I'm gonna have like Excel quote errors. You have to like, have you ever done this before? You have to like, I'm just gonna try this once and see if it works. It's been a while since I did this, so I should have actually prepared for this before live streaming. Fatal mistake. Let's see. I think it's like quote, quote, quote to get quotes in your Excel concatenation thing. What the fuck? And what are these quotes? Oh, those are my empty quotes where I was going to put in the contents of cell B2. not possibly going to work. I'm going to be like, just end up copy pasting this. Let's see. If anyone out there has some help on this, let me know, because this is not looking good. All right, this is never going to work. I've lost track of all my quotes. What should my plan B be? Well, a reasonable plan B is just to like copy paste them one by one. It would be a lot better if I could get this to work. What if I like do something crazy, like do these with single quotes, but does JSON require double quotes? I don't think it does. Or maybe it does. Anyone out there on the chat know? I can turn these all to single quotes and then like turn them back to double quotes later. Yeah, it was worth trying. I feel like I could maybe get this to work like with one more attempt. Like what if I get rid of the quote problem like that? All right, so now this is looking better. So now I just have to get my my Excel thing to work. So this should be A2. All right, so now I've got my number for the version, my new metric ID. Wait a second. Would be also A2. Not working. New metric ID 0. Event to measure. Now this has to be B2. Okay, this is actually looking like it might work now. Because now, well, actually, I'm gonna not try the whole thing just yet. I do have this quote problem, which, you know, most of my random text editing, I hate to say it, I like to do it in Sublime. I don't know if you know Sublime, but it is a great tool for just doing a little text edits. Hold on. So what now I need to do is wait, what are these extra quotes here? Let me just try replacing single quotes with double quotes. All right, now let's see if I can put this example back in here and get it to run. What is wrong? Okay, JSON check. Oh, there's like an extra quote here. That's definitely a problem. And oh, and I'm missing semicolon. I'm missing a semicolon. I'd better fix that in my Excel formula. I kind of thought like there wasn't a semicolon there. So it would have to be like that. Okay. Okay, at this point, I should actually be able to try running this. Did I give it a go? I guess so. I'd better see how well I've done before I copy paste it a bunch of times. Let's now make a configuration. I'm gonna duplicate this. This will be, whoops, 3 multi-event count insert. Listing 3, now I'll do dash version 0. That'll keep it simple. Event 0, version 0, ID 0. Should be easy enough to remember. Okay, I think this looks good enough to actually risk running it. I've saved this. Yep. Hi, Night Toad. Oh, cool name, Night Toad. Yep, this is for the book, but it's actually a more advanced data set than was in the book. And I'm basically redoing some of the stuff from the book, but with a more advanced scenario. Much more realistic, actually, which is what I like about it. So let's see if this works. Gonna cross my fingers and see if we can actually insert something into the database. All right, it's running. Okay, this is looking good, looking good. I don't know how long this will take, actually. Well, I guess I can let that run while I go back to monkeying around with my configurations. All right, so I think this looked good enough. This worked, so I'm gonna go ahead and like copy it a bunch of times. And now I'll have 25 versions of the own. And for those of you who've never done this before, this is a good trick for generating configurations. You can generate JSON or YAML or any kind of configuration files you have. I think this should be good. Now let's see. Has any result returned yet? Not yet. It's taken a while. All right, so I'm gonna need a comma here. Let's try pasting everything in. Oh no, I need to actually deal with my single quotes. Fortunately, I still have Sublime ready here with the search and replace to get all my single quotes into JSON-friendly double quotes. Yeah, I generated a repeated JSON entry in an Excel. It's a kind of stupid trick, and I don't know, if I had a better... Oh wait, something's wrong actually. There's extra quotes. What the heck did I do? Let me go back to this. Where do I... Oh, so... I'm like staring at this. Where is the extra quote coming in? Oh, here's an extra... Oh wait, that's the closing quote. Can I fix this just by searching and replacing? I think I can. Let's see if this fixes it. Get rid of all those little dangling quotes. Like, where did these all come from? Well, this was not quite as smooth as I had hoped. But since this is a live stream, I'm just going to try to, get done with it now. So I want to replace all these extra ones as well. I don't know how that went so badly wrong. But I think I recovered. Let's see. All right, looking good. Probably need a trailing comma here, or no trailing comma. Oh yeah, JSON is Python gets trailing commas. JSON actually does not like trailing commas. Okay, I think I'm finally done. This actually looks good. A few extra spaces here. But this is taking forever. Oh no, it finished. Okay, I wasn't paying attention. Okay, I always like to look before I leave. So let me go and double check that I have actually inserted something into the metric table. Let's just, well, I can reuse this query. Okay, I have inserted rows into the metric table. Kind of randomly organized, and we can see select count star from metric. Okay, decent number. Actually, let's do a group by to there should only be one metric ID because I just started out with this simulated schema for the first time. Oh, what did I do wrong? Select count. Oh, missing a comma. Always something, isn't it? Life of a hacker. No, what else am I doing wrong now? Perhaps you mentioned metric. Geez, what are the columns in the metric table? Let's go back out here, and can I easily remind myself of, like, I don't even remember. What are the columns? Account ID, metric. Oh, it's not metric ID, it's metric name ID. All right, that was what I was trying to say. What I wanted was metric name ID, because this one has a join with a name table as well. Metric time. No, this is what I want. Oh no, I didn't change it in the group by. Okay, does that happen to you too? You change your field in the select statement, but forget to change it in the group by. Only about once a week, I suppose. Not too bad. But anyway, After an excessive amount of thrashing, I have achieved the result of showing that I have inserted one metric into the metric table as a result of using listing 3.3. And that was the goal. And so now I've also added all these other versions to run. And I've only gotten one of them finished, but I think I can go ahead and just start running them. It's going to take a while because you saw how long, one went, but I can just start running it. We can just let it go. The question is, how much parallelism do I want to use? Probably not too much. I actually haven't run anything parallel in here for a while. I have to check the configuration for it. Let me just, what is it actually? Here's another little thing in the code. Where are the arguments for the churn listing running program? It's here. So if I want to set the number of parallel, I will add this argument. So this is in the run churn listing. It's just like the wrapper script I use for the book listings. So I want to do this a little bit parallel. My database in Google Cloud can definitely handle the parallelism, but the truth is I don't want to hammer my laptop too much while I'm live streaming, or my live stream might come to an abrupt end. But I do want to use some parallelism just so this doesn't take all day. Maybe I'll do in parallel 4. The database does most of the work here. So now I've just got to go 1, 2, 3, 4, 5, 6, etc. Why don't I just start with this? And if these complete, then I can run the rest off stream. But this is just kind of for demonstration purposes. I'm going to try to run these 8 versions. It should use parallelism when it does this. Let me just double check my configurations one more time. Okay, looks good. Crossing my fingers. If it doesn't work, I'm probably just going to fix it offline. Not actually that exciting. Well, it does appear to be working. You know what we could do, which might be kind of fun, would be to look at the workload on my Google Cloud Postgres database. I worked with a company where people pay in advance. So there is no monthly renewal. You pay in advance for the following period. I guess annual products generally work on that basis. Or wait a second. Don't people mostly pay in advance? I'm trying to think. For my Netflix, am I paying in advance at the beginning of the month or at the end of the month? I think usually, I don't know anyway. I'm not sure. Someone tell me that. Do you pay for Netflix in the beginning or the end? But enterprise software, you generally pay in advance for the following period. If you sign up for Salesforce for a year, I don't think they comp you a year and then let you pay at the end. I think you got to pay up front if you're a new company for enterprise software product. I'm not really sure though. Yeah, I think probably in advance. Thank you, Night Toad. Cool. All right, so what was I going to do? Oh yeah, we were going to try to look at the load on the server. Okay, that's YouTube. We don't need to look at that. Let's see if we can get something on my Google Cloud Console to show that the Postgres database is actually doing something. Okay, yeah, look. Maybe this was one of my selects from before. Look in the last hour. Maybe this was my first calculation and the second one hasn't really hit it yet. This might have been the query I did earlier in the stream. Well, I just launched 4 more parallel calculations of a feature, so I'm kind of expecting to see something here. All right, well, we can check back on that a little later. Cool. Anyway, what else? I think this is actually most of the stuff I was doing for the stream. So I actually configured and ran the metrics. That was pretty much the idea. Oh, quality assurance. So we do have one one additional topic for the stream today. The question is, is a good way to check that your data is good and your feature calculations are good? And one way is to look at just time series plots of the metric. So here's some summary statistics you might want to calculate for a metric. Well, a metric or feature, I use the terms kind of interchangeably. So these metrics are going to be the features when you put them into a data set. I guess that's why I call them metrics at this stage, because it's not a machine learning data set yet, which is one of the distinctions Challenge Project 43 was getting into. So suppose we want to do this. Calculate the maximum metric over all customers, the average, the minimum, and the count, which are some nice summary statistics. Well, I already wrote some code to do that in SQL in the project. So let's take a look at listing 3.6. Again, these are going to be some simple aggregate statistics, but now actually they're going to be on the metric table itself and not on the event table. Before, the metric is an aggregate on the event table, and now this is an aggregate on the aggregate. So this SQL is pretty similar to some of the ones before. Again, I calculate a series of dates where I want to generate these statistics. And then I'm going to select just those rows from the metric table, which is, I think, convenient. You don't really have to do that extra step in the SQL, but it makes it a little simpler. And then because then the final query is just a group by over the calculation date and getting that average, the count, the min, the max. So pretty simple. Now, honestly, I have no idea if I've configured this for the new CRM simulation. So let me go look in here. I don't remember. Okay, look, I didn't. I have not configured this. Okay, then. It looks like I have another little chore to do here. Sorry for this. I actually didn't see this one coming. All right, well, since I already did this once in this stream, it should be pretty easy. It should be this one, metric stats over time. And you know what? I'm just going to do a quick, more lightweight version of this. I'll just set up enough to demo, but I won't set up every one. That would be abusing your patience as an audience, I think. All right, so now I'm going to put in a version of listing 6 here. And I just need to actually provide a default parameter. Okay. I also am going to need to insert the metric name because, right, I do need to insert a metric name. That was the other part of the demo. So I'm going to adjust this up. This is going to, remember we calculated that first one for advanced stage per month, right? I think that was was that the first one? I have to double check. What was the first one that, oh no, it was only search. Sorry, the earlier demo was, this is gonna be search per month. All right, so I'm just gonna insert this one metric name, which I need to do to run the other query. So again, this is a live hack, and it'll illustrate messing around with the fighting churn with data code and simulations. Because honestly, the new simulation for CRM5 is still a work in progress. Kind of a hobby, you know, because I do have a day job. That's why I don't just sit around, you know, setting up fighting churn with data code all the time. All right, I want to run listing 4. This does not need to be in parallel. So let's just see if I've successfully done that. I'll run again. All right, now, as always, let me just double check. Did I insert my metric name? Metric name. Okay, search per month. All right, that's what it was supposed to do. So now back to setting up listing 3.6, which is going to be the metric summary. No, wait. This is... Metrics, okay. This is supposed to be now search per month. And I guess you have to put in a save extension here. All right, now we can finally run the metric statistic query, which I already showed you. Just to remind you, what was the metric statistics? Oh, did I close that? Well, let's get that open again, just because we're supposed to be paying attention to the code. All right, but I also, as always, need to set up a new configuration. So this will be metric stats SQL 3.6, and this should actually just save the result in a file. Let's see. Okay, first, wow, that was quick. Okay, it looks right though. I'm just double checking the dates, 2022 to 2023, search per month. Looks good. Let's look at the output folder. Okay, here it is. Something appeared there, and yeah, the little preview from my Mac is showing me that there is data in it. Okay, so we're good. So now the only remaining stage is to look at the result. Well, I think I have a slide for this. 3.6. So the next one is to make the nice looking plot like I showed in an earlier slide. And for that, I'm actually going to go to the first Python listing in the whole book. Yeah, so this was the metric QA plot, which takes that output and turns it into a plot. So let's look at listing 3.7. Very simple. This is like the simplest Python you're ever going to do. It's really just a simple matplotlib exercise is all it is. It's going to load that file we just saved and put it into a data frame, make a plot, and then make some subplots. Subplots 1 through 4 with the max, average, min, and the number of calculations. Oh, question. Do I have a stream schedule? Yes and no. I pretty much always stream at this time, which is Saturday, kind of midday. And the reason for that, I think I mentioned earlier, I have a day job. So I'm usually not streaming in the evening because I also have a family. You know, I got the works. What do they call it? The full catastrophe. Job, family, mortgage, everything. So if I'm going to waste time live streaming, it pretty much has to be on the weekend. And I'm going about once a month now is what I'm aiming for. So the week, it's generally going to be about a month apart from stream to stream. Living the dream? Yeah, I guess so. Thank you. Thanks for your support. All right, so let's run this query. I guess, oh, actually, should point out, this is actually my own little sub function here where it does the repeated code necessary to make one of those subplots by calling the subplot function, doing the plot, setting the y limit. So that is just how I wrote some nicely refactored code. I guess I could have done it even better by calling this function in a loop or something like that. I could have made a list of the strings max, and I could have enumerated them. That would have been even more refactored code. But anyway, we don't have to go there. Let's just run it and get on with this. This one just has to metric stats plot, and this one is going to be 3.7. So hopefully this all works the way it's supposed to. Oh no, exit code 253. That doesn't, no listing in chapter 3. Oh, okay. I didn't set up the configuration. So once again, here I am. I will copy paste a little simulation from the book configuration for the social network to the CRM simulation. Indeed. Now, so I'm really like filling in all the missing listings. So you see I've done a bunch of listings set up for the new CRM simulation, but I haven't hit everything. Oh, wow. Good thing I look at this. I have to update this. If I don't have this path correct, whoops, it'll definitely not work. It has to be all CRM6. And this will have to be search per month, because that's the only one I've done. Hey, I wonder how the query inserts are going. Shouldn't they be maybe that completed too? Well, I'll check that in a minute. Metric stats plot. Like, where's my other run? I'm a little confused what happened to my other window. But anyway, let's just go ahead and run the metrics stats plot. All right, it's actually working, saving. Okay, so now we've saved that plot. So simple SQL aggregation. Whoops, we want to actually look at the results. What do we get here? So we just created this. Okay, so here's our result for the metric search per month. After a short build-up period, the maximum value hovers around 5,000. The average value is in the range of 80, I'll say. The minimum is 1, I guess, so no one has 0. And this is the number of accounts that it was calculated for. So you can see the service has a gradually increasing number of accounts over time. And there's too many dates to really see it on the x-axis, but I'm not going to try to fix that right now. That would be a little excessive. But yeah, there's an example of the search per month. Now, like I said, I'm wondering what happened to my metric inserts. Did those complete? Let me go back to my group by on the metric table and see. Oh, okay, look. I have a bunch more metrics calculated. 1, 2, 3. Okay, so numbers 0 through 8 have all completed successfully. I do have to insert all the names, but I'm going to do that later. But for right now, I'll just go ahead and calculate another set. Metric event count insert. Let's go into this one. I'm just going to launch some more of these. 9. We'll just kick these off so I keep getting some more stuff done in the background. Okay, Challenge Project 43, you said, I am actually working now for a streaming TV company. Oh, sweet. Which one? And customers have the most unpredictable behavior. Oh, yeah. Some don't have any drop of watching before churn, so it's hard to predict using their watching behavior. Yeah, I bet some people even increase before churn. Usually, some people binge right before they go. Others have even set properly their password, and they still keep paying. That's true. Any advice on how to handle this? Streaming churn is really hard because it's well known that people, they do like churn and return. God, I shared something on social media about this. Should I look in my old posts? But I posted about this on LinkedIn and I post the same shit on all my social media. But I posted this churn and return where people just cancel because they watched the whole season that they were interested in. And then they come back when there's a new season. Or for sports, if it's sports streaming, this is very common. You sign up when the sport you like starts, and then you cancel when your season is over, and then you start again next year. So for streaming churn, definitely make features based on specific series, like the popular series that people might binge and then dump. And if it's sports, be aware of annual seasonality. And make features that are based around, number one, figuring out what is the season that what is the sport that this viewer likes, and then what is their season. Yeah, reconnect guys, we call them. Oh, cool. Can you tell the audience what streaming service you work for, or is that will you get fired for talking about it live on Twitch? We're always interested I've worked with a few streaming services, and actually OfferFit, my company, it's no secret that we work with the binge streaming service in Australia. I'm pretty sure we have like a video. You can see OfferFit works with, there's like a video of us, like, you know, a case study video. Oh, it's in Western Europe, in the Netherlands. Okay, cool. Yeah, well, at OfferFit, we're working with, Binge in Australia. And in the past, I worked with, my first startup, we worked with some niche video, art house video. God, I forget what they're even called now. But anyway, I've worked with a few streaming services, and definitely paying attention to if it's like a regular video service, you want to pay attention to what series people are watching. And they might sign up again when their preferred series launches a new season and churn right at the end, you know, once they've binged the current season. That's what the regular services face. Anyway, I think that actually is everything for this stream. So we can kind of like just keep talking about whatever. Yeah, this is the stream summary. What did I do this stream? Well, as in every stream, fighting churn is about targeted interventions, improvements, engagement, and support. Events are raw data. That's what we saw. We were definitely looking at the events. Aggregate features summarize each customer's events. And that's basically, those are going to become the machine learning features when we actually make a machine learning data set, which does come kind of later. Features can be calculated in a database with SQL, and this is definitely the best practice, not to do it in Python. I know data scientists, we all love Python nowadays. It's very tempting to take your raw data into a pandas data frame and use the aggregation to calculate your features. And that is fine, except it doesn't scale to big data. If you've ever tried to work in big data with Python pandas, you have surely regretted it. And that's why you do this in SQL, because it easily scales to big data sets. Not really using Postgres. I'm actually just doing even a toy example here in Postgres. But like I mentioned earlier, you know, in my companies where we do this, we use Google Cloud BigQuery, you use Snowflake, or you use AWS Athena to do these calculations for big data. And the same SQLs work. So anyway, in the database with SQL, and let's see, time series statistic plots are one way to perform quality assurance on the metric. Now, I think in the next stream, we are going to do more types of quality assurance on the metrics. What am I using to handle SQL queries? I am using, what is it in Python? It's something. Let's look. What am I using? Should be up here. Hey, this should... Okay, I'm using Postgres. Is that it? I thought I was using some other... But yeah, I guess for this part of it, I'm just using Postgres. Yeah, I just make a connection with the Postgres library. In one of my other areas, I use like that scikug something library, but I know Postgres is actually built on that. Probably in the requirements. But yeah, nothing fancy, just like, you know, piping the SQL queries in Python and sending them to the database. In this case, I'm running the database on Google Cloud, which reminds me, let's see if there's any sign of life here. Is there any more sign? I mean, I ran a bunch of queries that were saving, and it was saving the result of the queries. So, okay. I guess this was my first metric calculation. This is the second batch that I was doing. I don't know. Maybe this is the first batch, actually. It's kind of like delayed here. I think these all completed too. Yeah. So it actually does them pretty quick. Is Google Cloud free to use? Well, yes and no. It is free for the first $300. So if you actually want to try to use it for a small project, they'll basically comp you. And $300 will go a long way. I started up my database this morning to prepare for the stream. I've been running it for several hours. It's probably only going to cost me like 50 cents or a few bucks or something. Now, the trap is, remember to turn off your servers when you're done, or you can blow through your $300 credit pretty quick. And you do have to sign up with a credit card. So yeah, you can play around with it for free up to $300, and then you have to start paying. That's how they get you. But what do you expect? All right. Yeah, I practiced before my current job just by signing up my own account, because I knew that my current company is on Google Cloud. So now I'm like a Google Cloud regular. But before, my previous company, actually we were on AWS. Yeah, I had AWS on my previous companies. Anyway, it's already a blur. Anyway, so that's pretty much everything for the stream. I will once again mention, sounds like some of the people on the stream today already know the book, but if you don't have the book and you want to get it, use the discount code to save 40%, or, get free shipping from Amazon if you're in the US. Your call. Let's see. Follow me for updates about everything. I post articles about Churn all the time, like about the streaming Churn. If you look in my post history in LinkedIn or Twitter or Mastodon, there's the Churn and Return article is a really good one for streaming. And Linktree is a link listing place. I don't know what you call it. It's like an app that you can just look, because people have so many social media. Now I am really on multiple social media trying to figure out where to spend my time in the post-X era. I've been spending a lot of time on Mastodon. I finally got an invite to Blue Sky, so I'm checking out Blue Sky a little bit too. Threads a little bit, not so much, but anyway, follow me somewhere to get any updates. Today's music was brought to you by Leak Beats Lo-Fi. I hope the music was not offensive to anyone today, because I wanted to mention actually that I don't know if anyone was on my last stream. Oh, thanks for the shout out for the book challenge, Project 43. Definitely, I think it was worth it if you do Churn. But about the music, I just want to know what people thought of the music and what people thought of the music on the last stream, because I got a comment on my last stream on the YouTube video. Someone said, like, great talk, however the background music is weird and disturbing. And I didn't think it was that bad. It wasn't the Leak Beats Lo-Fi. I think last stream I tried out like a new music, and then someone actually was like, yeah, found it disturbing. So if this music was weird and disturbing, let me know. It's meant to be very inoffensive and, kind of like grooving background music for concentrating, coding. All right, what else? Thank you for being here with me, especially today to Night Toad and Challenge Project 43. And I like to give shout outs to people who followed me recently, especially those with cool usernames like T-Rex Neutron. Thank you for following me. I don't know if you're out there, but hopefully maybe you'll watch this stream later. Another person with an awesome username who followed me recently was Be Batman. Thank you for following me, Be Batman. And who else have we got here? A lot of people have interesting names this week. Next comes, I'm not sure how to pronounce it. Decrypted HN. Thank you for following me. Oh wait, and Night Toad, you started following me in the middle of the stream and I didn't even notice it. So thank you. I can actually, in the streaming software, I can replay these things. Kind of funny. So yeah, thank you for everyone who watched, and especially everyone who kept me company on the chat. And as usual, this stuff can all be found on YouTube sometimes later. I never know why I'm saying that to someone on Twitch. And the truth is, if you're on YouTube, you're already there. So I don't even know why I include this. All right, my next stream, I'm targeting January 6th. Like I said, I have time to do this about once a month. I'm going to keep moving forward in the book, and we are going to do stream 4 in the masterclass subscription features. And this is going to be a very exciting stream because many of the subscription feature sequels, which were in the book, the queries, were not really useful for the social network simulation because it didn't have a lot of features. But with the CRM simulation, it's really going to use all the different types of queries. So should be fun. Some stuff that was not really covered that well in the book. The new simulation makes it possible to do much more interesting examples. Oh, hey, you thought the music was okay. Thank you, Challenge Project 43. That's some good feedback. All right, and I'm glad this helps you. So cool. Thanks for being with me here today. I guess if you're in the Netherlands, it's pretty late for you too, but I guess that's cool. For me, it's just the middle of the day, and I'm pretty much gonna get on with my day, get back to walking my dog, doing my errands. You don't want to know. Living the dream here in cloudy Bay Area, California. We got some serious fog going on outside. But that's it. Thanks, everyone. Have a good rest of your weekend. I'm out.